Hello, somebody. Hello, wherever place you are. I'm David Kyle, the owner of the channel, the YouTube channel, the Teacher Kyle Explains, especially containing chemistry and some physics or principles in it. Now, do me one favor. Make sure you like, you share, but more and more, make sure you subscribe to my YouTube channel. Teacher Kyle Explains. It contains a lot of things, especially that are meant for our learners in school. Now, without much ado, let's go directly into our class. Thank you. Wow, thank you so much. Now we are looking at liquid mixture. There are two types of liquid mixtures. We can have what you call immiscible and we have what you call the miscible. Now, for the miscible, we can also have what we call the separating funnel as one of the apparatus of removing or of separating the immiscible liquids. Now, we also have decantation. We also have what we call the dropping funnel. Now, I want to explain something here before we continue. Now, for the separating funnel here, what you need to understand about that one is this. Let me draw for you something here. Now, assuming that this one here is our funnel, let us got a stopper and hold that one. You've supported it, you've supported. There is a support there, there is a container. Now, this is what you need to understand. That, for example, if you've got water here, and at the same time there is oil that is up there. Now, if that is the case, during this process of using the separating funnel here, now there is an opening. The moment you open this opening here, water will come down, so that you'll have your water, and whatever will be remaining here will be the oil will be remaining. This will be water. So, but this process is not that good because we have a place called interface. Interface is a region in which it is a part in which now it looks like oil and water mixed. It is like a boundary between the oil and water. So that is to tell you that the moment you reach onto that point, you take that interface, you take that liquid, you throw it away so that you remain with the oil. And that is why I'm telling you it is not that much appropriate. It is not that good. Now, that is what you need to understand in the separating funnel. We also have decantation. During decantation, also you can have two containers, just like the way I was explaining it in the last class. So you could use two containers. One container is down, the other one is up there. So the moment you tilt the container, the liquid which is up there will go down and you will be remaining with the other one. So we also have the dropping funnel. It is working the same as the separating funnel. That is what you need to understand about this one. So, but these methods here, they are not that much accurate. So that means there is a problem when it comes to the separation of immiscible liquids, especially when you're using this apparatus here. Can we now go into the miscible? Now, miscible means that the two liquids are able to mix one another. For example, if you take ethanol, if you take water, these ones here, if you combine the two, they become one. So there is no separation there. They become one. And therefore, for you to separate these two here, you cannot use a separating funnel. How can you even use that one? How can you use decantation? How can you use dropping funnel? You cannot use, but you will have to come up with what you call the fractional distillation. It's one of the best methods which you can use, especially if you want to have the two liquids on separate containers. Now, this is the diagram that I want you to look at. Now, in this diagram here, we have what we call the glass beads, and we have also what we call the thermometer. We have also what we call the solution. We also have the Liebig condenser, and also there is also the distillate, which you also need to understand and know in that case. Now, look at this. This ethanol here is the boiling point 78. Sorry. 78.2 degrees and water is 100 degrees Celsius. If these two here were mixed together, how are you able to separate the two? Now, here is that solution containing the two. The moment you heat, it will reach a point where now 78.2 degrees Celsius will be reached. And therefore, this ethanol will will be ejected. It will get out as a vapor into another container, which is, we can say that it is container B, and this one here to be our container A. So in container A, ethanol is together with water, but the moment you heat, the boiling point of this ethanol will be reached and it will go into a container B. So whatever will be remaining here is 100 degrees Celsius, that is water, will remain here because the boiling point has not been reached. Now, can I shock you? Now, we also have some traces of water. The moment you do the boiling and you heat this solution, it will reach a point where like water vapor, some of the water particles may want also to go with the ethanol. But in that case, now the fractionating column now comes in. It will condense that liquid and it will come back into container A. So you will have water coming back because the boiling point has not been reached. What is the purpose of the glass beads here? The glass beads are there to increase the surface area. The surface area is, in fact, the surface area of condensation. The light bead condenser is here also to increase the efficiency of cooling. We have the water out and also the water in. The water out here is very hot and the water in here is very cold at A and also at B. That is what you need to get there. Distillate, I told you, is a liquid which is formed, or is that liquid which is collected in the process of distillation. Now, what is the secret behind this one? The secret behind this process is the difference in their boiling points. If the boiling points are very different, then the best method for you, which you need to use for you to separate between the two liquids, is what we call the fractional distillation. NB boiling points needs to be very different for you to get there and for you to even to understand. I've explained this one. Where do we apply? We apply in the fractional distillation of liquefied oil. We also apply in the extraction of oxygen, nitrogen, and argon in a fractional distillation of liquefied air. But this one here is fractional distillation of crude oil. If you want to get components of oil, for example, the tar, if you want to get maybe, for example, maybe if you want to get another one, maybe the grease, if you want to get the other component of oil, so you need to use what we call the fractional distillation. And this one here, we will tackle it when we reach into Form 3 work. This one here, we will look at it by the end of our lecture, especially in this topic, in the second last topic of Form 1 work or Form 1 work. That is what you need to understand. Now, there is the other method I want you to know, is what we call the solvent extraction. Solvent extraction makes use of two things. We have what we call unequal solubilities, and also we have what we call adsorption. But I don't want us to look at adsorption, but I want us to look at what we call unequal solubilities. Unequal solubilities are very important. In other words, the solubility of the oil and the solubility, for example, of the propanol, which we will look into the purpose of this propanol, their solubilities needs to be very different for you to get it. Now, assuming that you've got nuts or you've got seeds and you are told to produce oil out of it, how do we go about it? Now, first of all, you need to do the crushing of the nuts or the crushing of the seeds using the mortar and the pestle. And if you don't know the mortar and the pestle, go back to I think the second or the third lecture where I was looking into the apparatus that are being used in the laboratory. After you've done the crushing, you do what we call addition of the propanol. After the addition of the propanol, you do what we call the decantation. For you to remove the propanol, for you to remove now the things which you crushed, especially the remains of the seeds or even the nuts, you do the decantation. Then after doing that one, you expose it to the sunshine. After exposing to the sunshine, you now put it on a paper, which is very nice. I will tell you this. Now, why do we do the crushing? We do the crushing so as you increase the surface area. Very nice, the surface area for dissolving, for the dissolving of the oil together with the propanol. Now, what about adding of the propanol? We add the propanol so that we may do what we call, you will dissolve the oil. Why are we not using water? Is because water can never dissolve the oil. Water can never dissolve the oil, and therefore propanol is the most suitable solvent which we use during this time. If you want to dissolve the oil, we do the decantation to remove the nuts or the seeds, or also we are looking at the sunshine. The purpose of the sunshine is for you to evaporate the propanol, and we put it on a piece of paper so that we may test whether the fat or the oil can be looked at. Very, very, very nice. That is what you need to understand. For you to obtain the pure oil, you need to do what you call the washing. You need to wash that oil in the pure water. Somebody will ask me, why should we be washing it? Because after all, oil cannot dissolve in water, and therefore you are removing the impurities. You are removing some of the remains of the nuts, some of the remains of the seeds, so that as you remove them, as you remove even the propanol, you are able to make that oil to be very much pure. Why do we apply? If you want to get oil from the nuts, then do solvent extraction. If you want to get the natural dust from the plants, do solvent extraction. If you want to get herbal medicine from the plants, you also need to do what we call the solvent extraction. That is what you need to understand, especially when it comes to solvent. It is a good thing. It is another name for solvent extraction is liquid extraction. It's a very important thing. Just put it in your mind. What if we were to eat food without oil? How could that food taste? So just understand the solvent extraction is very important for you. Now, in the last part of this, in the last part of this thing that I want, if you enjoyed today's class, and I do believe that you got a lot, you enjoyed. Have you subscribed to my YouTube channel? Please, if not, do it once again. If you cannot do that, you won't see me. Thank you.